In this video, let's take a look at Perceptron. It all started with Frank with his paper in the 1958. Yes, this has been around for a while. Now, in order to understand, we have taken an example. In this example, the idea is to use a perceptron to make a decision based on certain input parameters. The decision is whether to drink coffee or tea. First, let's take a look at the structure of a perceptron. Then we will go into each stage individually. The first stage is the input stage. In the input stage, we have the input parameters. Let's take a look. The first parameter is the weather. Now, if the weather is cold and rainy, you're gonna make it as 1, else 0. So this is a binary input you're giving to the perceptron. So you're saying if the weather is cold and rainy, you input as 1. So that's a binary high. The next parameter is called situation. So the positive situation is a lot of work to do. So that means you're going to give a 1 to the network. If there's any other situation, you're going to pass a 0 to the network. The next parameter is sleep deprivation. If it is high, then you're going to pass 1, else you're going to pass 0. So just a quick recap. So we have the input layer. In the input layer, you have the input parameters, and based on the input parameter, you are evaluating and sending a binary input to the perceptron. So you're going to send either a 0 or a 1. Now let's take a look at the next stage. The next stage consists of the weights. So what are the weights? Weights are basically the importance you want to give to a specific parameter. Let's take a look at it. So the first parameter, the weather parameter, it is somewhat important. So we're gonna give a score of 30% or 0.3. The next parameter, which is situation, is very important. So we're gonna give a score of 50% or 0.5. The next parameter, which is sleep deprivation, matters somewhat. So we're gonna give it a 20% or 0.2. Now let's take a zoom out and try to understand what's happening here. So far we have the input layer, which has a set of input parameters, and we have the weights, the importance of each input parameter. Now, in order to move this combination of input and weights to the next stage, we are going to take a weighted sum of the input I and the weights W. So let's take a look at how to do this. So this is the math behind it. For example, let's say that it's a rainy Monday after a rather relaxed weekend. So the first parameter, which is weather, so we said that if it is rainy and cold, you're going to give it a 1. So there you go, this is the 1. Now in terms of the weights, the importance was 0.5, so you have the 0.5. Now the weighted sum is basically to multiply your input I with the weight W. In this case, I1 and W1. So that product is 0.5. The next parameter is the situation. So it's a Monday morning, so there's a lot of work to do, and the importance is 0.3. So the product is 0.3. And the last one is the sleep deprivation. Since we had a relaxed weekend, so we are all good on the sleep, so therefore it's a 0. Now this product becomes 0. Now if you sum all of this, the output is 0.8. Alright, so far so good. Let's zoom out now. Now so far we have input, we have weights, we have weighted sum. Excellent. Now what we're gonna do is we're gonna see what is a bias. Now bias has many functions. One of the function is to force an output. Another function is to influence the next stage, which is the activation function, among many others. So we're going to use a bias of 0.2. Now this can be a positive number or it can be a negative number. Obviously, depending on which trend you're going to use, this is going to affect the next stage, which is the activation function with the same trend. Now let's take a look at the next stage. Perhaps this will make more sense. The next stage is the activation function. Now what is this activation function? You can use many linear and non-linear functions in this activation function. One such example is called as a step function, which is also a basic linear function. So this function is basically saying that if the output is greater or equal to 1, then make this as a 1. If the output is less than 1, then make this a 0. It's very straightforward. So what this means is if it is 1, then the decision is to drink a coffee, and if it is 0, the decision is to drink tea. So that's how we make decisions with Perceptron. Now let's zoom out and take a look at it again. So we have inputs, which is basically the parameters. Next, we have the weights, which is the importance given to the input parameters. Then we have a weighted sum, which is basically the combination of input and the weights. Then we have a bias, which is added to the weighted sum. The next stage, we have the activation function. So this function basically classifies the output into a binary fashion. So let's take a look at the output. So you have zero point 0.8 from the weighted sum, and then you have a zero point 0.2 from the bias. That makes it an even 1. So 1 is equal to 1, which satisfies the step function for coffee. So therefore you're going to be drinking coffee. Great. Now this is a very basic example of a perceptron and how this goes about performing a binary classification for the given input.